All right, today's lesson is 17.1, graphs of sine and cosine. This will be your last formal trigonometry lesson for the quarter. All right, so talking about what a graph would look like for sine and cosine, no worries, you won't need graph paper. This will all be done by hand. So if I look at y equals sine of x as a graph, so this x would be your input variables, or kind of your x-axis. All right, so when I'm plugging something in, that's going to be an angle that you are plugging in, right? So sine of an angle, cosine of an angle. So my output would be y, so that's going to be the ratios that we get. Okay, same thing with cosine. Y equals cosine of x. You are plugging in an angle. What you get back out is the ratio. Okay, so oftentimes we make graphs, right? We do things and you make a table. You plug things in like, oh, -2, -1, 0, 1, and 2. But cosine of 1 isn't anything special that we know. So we're going to need to be smart at what we choose for our angles. And our angles are going to be in radians. The higher levels you go in math, the less you're going to use degrees. All right, radians is used most in the trig elective. It's going to be used most in calculus and beyond, if you go beyond. Okay. All right, so we are going to make tables of each of sine and cosine. But like I said, I'm not going to use that typical, I don't know what you taught in middle school, use -2, -1, 0, 1, and 2. All right, I'm going to use still some basic trig functions, and I'm going to go back to the unit circle for a second. So I'll make tables for both of these. But I'm going to use, so if I draw my circle, I'll use my color. I'm going to use these 4 points as the points on my table. Okay, so remember the unit circle? Each of these lines would be a length of 1. So this is the point 1, 0. This is the point 0, 1, -1, 0, and 0, -1. Okay, we could use things like pi over 6, pi over 4, and that sort of thing, but we're going to keep it a little bit simpler. So the only things that I'm coming out with a y value would be 0, 1, or -1, because that's easier to graph than the square root of 2 over 2. Okay, that's a little bit messy. We need the decimal. Okay, so we want something a little bit more exact. So that's the reason why we're going to use these values, but I need the angles that I'm going to plug in. All right, so 0 will be the first angle I plug in for both of my functions here. Next, I have up here would be pi over 2. Okay, coming around right here at my point -1, 0 would be pi. And then I have, so that was pi, now I have 3 pi over 2. And then back around would bring me to 2 pi. All right, you can continue this forever and ever, and we could go 5 pi over 2 and keep going around and around and around. And you're going to get the same things over and over eventually. All right, these are cyclic functions. They keep repeating the same y values over and over. Okay, or periodic would be another way to describe it. Okay, so let's go ahead and plug these things in. So this first one, if I'm doing, and some students like to think of it as y equals sine of theta versus sine of x because they get kind of confused. So I'm plugging in sine of 0 radians. Okay, so if I want 0 radians and I'm with sine on my unit circle, I use the y-coordinate, so I get 0. The next one, sine of pi over 2 radians, I use the y-coordinate on that point, so I get 1. Sine of pi, the y-coordinate at pi would be 0. Sine of 3 pi over 2 would be the y-coordinate here would be negative 1. And then when I go back to the beginning, I get 0 again. All right, so if I kept going around, it would repeat 0, 1, 0, negative 1, 0, 1, 0, negative 1, 0, over and over and over. Okay? If we look at cosine, cosine's very similar. It's going to have the same numbers, but in a different order. All right, so if I'm finding cosine of 0 radians, I'm looking at the x value. So that's 1. I'm looking at the x value. So 0. The x value, negative 1. The x value, 0. And the x value again. Okay, and then it would repeat over and over and over because we can keep going around and around as many times as we want. Right, I could have you find for 4 pi or 6 pi, right, going 3 times around, 2 times around. Okay, all right, so we're going to use that. We're going to look at a graph, the general graph of these. So let's look at y equals sine of x as a graph. Okay, so our y value, the highest we go is 1. The lowest you go is negative 1 if you look at that table. The x values that we're plugging in would be 0, and then I've got pi over 2, pi, 3 pi over 2, and 2 pi to make up those 5 points that I have in my table. All right, so I've got the point 0, 0. I've got the point pi over 2 is at 1. Pi is at 0. 3 pi over 2 is negative 1. And then 0. All right, and we can look into this in more details and kind of look at, well, between 0 and pi over 2 is you're going to have your pi over 6 angle and your pi over 4 angle and your pi over 3 angle, and we could look at them all as decimals and kind of what happens, but I'll just let you know it makes a curve shape. All right, and it would continue and go up and back down and up and back down forever and ever. Okay, from where you start, and so we make this start here, and we kind of, that's completed half of this cycle, and then there's the full cycle, and I'm back at the beginning. That's considered one period for sine. And we're going to talk about that in a little bit. Okay, let's look at cosine's graph. Same thing with cosine. The highest it goes is positive 1. The lowest it goes is negative 1 at this moment in time. We have the same x scale, pi over 2, pi, 3 pi over 2, and 2 pi. All this is coming from our unit circle from yesterday. All right, so when I look at my table for cosine, when I have my x-coordinate of 0, my y-coordinate is 1. So cosine is here to start. Next, when I'm at pi over 2, we had 0. Next at pi, it's at negative 1. 3 pi over 2 is 0. 2 pi is back at 1. So I've completed my one full cycle or one period of cosine. And it would keep going. Okay. What you'll notice is sine and cosine, they have the same patterns, but where they are starting is in different locations. So we won't have the exact same graph for both. All right, so sine and cosine are periodic functions. The period for sine and cosine is 2 pi for their general graph. So from 0 to 2 pi creates one full cycle, and then it will repeat over and over. Okay? The amplitude is the distance between, kind of this is the center of my graph is the x-axis right now, the distance between the highest point and the lowest point from that center is 1. For the sine and cosine parent graphs. In Algebra 2, we talked a lot about parent graphs and transformations and shifting things up and down and left and right, stretch, compression, reflection. The same thing can be done with cosine and sine graphs. Okay? So we're going to look into graphing things that are not just the parent graph. All right, and we are going to graph things in the form y equals a times sine of x, or y equals a times cosine of x. And we're going to do this for 2 periods. Okay, now you're going to have to match graphs in Math Excel, or you're going to have to look at the graph and create the equation from the graph. Okay, so we're not going to practice it quite like that. We are just going to go ahead and graph them, and if you can graph it, you should be able to match it. Okay, so my first example is y equals 2 times sine of x. So I'm filling in that a value, and this is your amplitude. So my amplitude is 2. Okay, so when I go to graph this, now since I want 2 periods, I'm going to go ahead and graph that pi over 2, pi, 3 pi over 2, 2 pi, and I'm going to do the reverse on the other side. So negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay, just like we did on the parent functions, but it's asking for 2 of them. Okay, the only thing that's going to change now, since I have 2 sine of x and my amplitude is 2, instead of being the highest place you go is 1, and the lowest place is 1, the highest is 2, and the lowest is negative 2. So we just stretched this graph vertically. Okay, so now I just need to get familiar with my pattern for sine, and I'm really just going to do the same graph as I had in this parent function up here for sine of x, right? We had 0, 0, up at 1, but now it's doubled, it's at 2. We go back to 0 and then to negative 2. Okay, so I've got my 0, 0. At pi over 2, I'm now stretched to 2 instead of 1. Then I'm back to the axis, down at negative 2, back to the axis. So that is 1 period. And I can do a couple different things. I can start here and go, well, I start at 0, I go up to 2, back to 0, down to negative 2, back to 0 to create my other cycle, or I could go backwards. And that would be my 2 periods. Okay, so the only thing that changed were the y coordinates. So it doesn't make it much more difficult. Okay, let's look at one for cosine, and let's look at if I put 1/2 cosine of x. Okay, so my amplitude is 1/2. All right, the parent graph is 1, so this is a vertical compression, so we just kind of crushed it vertically versus in the last time we stretched it vertically. We're going to make 2 periods again. So I'll go ahead and make my scale pi over 2, pi, 3 pi over 2, 2 pi, and then the negatives on the other side. Okay, up to you how you want to kind of sketch this, and just make sure you're looking at it. Sometimes I've seen it in Math Excel, they'll label it as a half and a negative a half, and sometimes they'll do 1 and negative 1, and then you'll see that it only gets halfway up there. Okay, so a couple different ways you can look at it. Sometimes Math Excel will do fractions on the y-axis, and sometimes they won't, and you'll have to kind of go, oh, if it's a third of the way up to 1. That picture looks like it makes sense. All right, so with cosine, a little bit different than sine, we do not do the 0, 0. Cosine had 0, 1 in its parent. All right, but now we just cut 1 in half, and we're using a half. So we go 0, a half, then we go down, then we go to negative a half, back to the x, and back to the 1/2. And that is the pattern every time. So I can start at 2 pi if I want and put it at 1, or I could go backwards. Oops, I put that at 1 instead of a half. Maybe I should put that lower. All right, and that would be the 2 periods that I would be matching and trying to find the graph that makes sense. Okay, so you have to pay attention to the y-axis and the x-axis when you're selecting those, because you're going to see these waves of things, right? Every problem is going to look like that. Okay, so we can't just pick the one that makes the cool waves. All right, they will all look like that. You got to pay attention to where it's starting and where those points are located. Okay. Something else we could see other than just a change in amplitude would be graphing y equals sine of bx. So there's a number in between sine and x, or in between cosine and x. And we're going to do this for 2 periods as well. Okay, so this will complicate things a little bit more than just changing the amplitude. So our first example with this is y equals sine of 2x. Okay, so what that term does that's in front of the x, it's going to change your graph kind of horizontally as a compression or a stretch. All right, so it's going to change the period. So the period right now is always 2 pi unless there is a number in between here. Then I must divide by that number. They use b. So I'm going to take 2 pi and divide it by 2. So the period is now pi. Okay, so that means I complete 1 full cycle of sine in half of the space that I normally do. Okay, so just kind of like a quick sketch, when it's at 2 pi, that would be the whole thing. Now, the whole thing is completed there. That's kind of dumb. I should have made it still the same amplitude. Okay, so visually, that's what's happening. So if you can kind of picture that from your graphs, if you're paying attention to the scale, now my scale has changed. Okay, if we kind of do it in the same sense as we've done it before, negative pi and positive pi will be where it's ending. Okay, so that means my x scale is all cut in half from what it was previously. Okay, so this is going to normally be 4 equal parts right here. So when I have 2 pi, it was cut into half pi, 1/2 pi, 1 pi, 3/2 pi, 2 pi. When I have pi, I'm cutting it into fourths of pi. That makes sense? Or the middle is a half. In between a half and 0 is a fourth. So I'm going by fourths. 1/4, 2/4, 3/4. And backwards. Negative pi over 4, negative pi over 2, negative 3 pi over 4. Okay, my amplitude is still 1. So the highest it'll go is 1, the lowest it'll go is -1. Okay, once I've kind of adjusted all this, I'm doing the same pattern over and over. 0, 0 is my starting point. All right, then I'd go up to 1, back to 0, -1, and back to 0. There's my full cycle. Usually it goes all the way out here to 2 pi. Right? Now I could complete 2 cycles within 2 pi. So you could graph it all the way out to 2 pi and call that your 2 periods, or you could transfer it and move backwards. Most of the ones when I was looking through Math Excel, they did kind of one on each side of your y-axis, so some positive and negatives. So trying to be consistent with what you would see. Okay, so this was a horizontal compression. Let's look at another one where we have y equals 3 cosine of 1/2 x. So I'm switching to cosine. My amplitude is 3. 1/2 is that b value, which means to find the period, I take 2 pi and divide by b. So 2 pi is a half. So when I take 2 pi and divide by a half, remember we're doing 2 pi times 2 over 1. So 4 pi would be my period. Right? As a visual of kind of what that means, right? Normally, 2 pi, 1 full cycle for sine. Now, it's taking twice the space to complete that cycle. That's what that means. All right, so we have a horizontal stretch. Okay, so that's kind of your comparison. So let's go ahead and graph this. Okay, so 4 pi is where my cycle ends, and -4 pi. So every time we're cutting this into 4 equal parts across the x-axis on the right side and the x-axis on the left side. So if I have 4 pi and I'm cutting it into fourths, I'm going by a scale of 1 pi. So pi, 2 pi, 3 pi, 4 pi. Negative pi, -2 pi, -3 pi, -4 pi. My amplitude is 3, so I need to make sure I'm going up to 3 and down to -3. This graph was for cosine. So cosine does not start at 0, 0, that's sine. All right, so I start up at 3 for the amplitude, then I go back to the axis, below, back to the axis, and back to the top. So there's 1 cycle, and if I go in reverse, okay, so it's the same pattern over and over, but we got to get familiar with where sine would start and where cosine would start, and then it kind of follows after that. Okay, I want to look at one last example. We haven't looked at what happens when we have a reflection. So graphing a reflection. So I've got y equals -1/2 sine of 4x. So the negative in front means that it's a reflection. The amplitude is 1/2. The amplitude is not negative 1/2. All right, the amplitude is representing a distance, so it cannot be negative. The negative is the reflection. So when you're asked for what is the amplitude in this problem, and when you type in negative 1/2, Math Excel will mark it wrong. All right, that's a very common error I see when people turn in paper tests and quizzes. So I just want to make sure I make that clear. We've got my b is 4, so I need to change the period for this graph then. And take 2 pi and divide by 4. So pi over 2 will be where this graph will end for one full cycle. Okay, so that larger that number, the tighter and smaller it's going to be, because I have to divide by that number. All right, let's go ahead and make a sketch for this graph. So I'm ending at pi over 2 and negative pi over 2. Okay, so I'm cutting pi over 2 into fourths. Right, so I'm making something small even smaller. Okay, or if it's easier, think of half of pi over 2. Half of a half is a fourth. Half of a fourth is an eighth. So we are going by eighths of pi. So 1/8, 2/8, 3/8. And the same in as their opposites. Okay, my amplitude is a half. So I'm just going to go ahead and label this a half and this negative a half. Okay, my graph is sine, so I got to think about, does sine start on 0 or does sine start on its amplitude? Sine starts on 0. All right, so now here's where my reflection comes into play. So I reflect this over the x-axis. So typically, sine would jump up here on a typical sine graph, but this time, since it's reflected, it's going to drop down first and then back and up. Okay, so same thing if I would have did cosine. Cosine would have normally started on the positive amplitude. It would start then on the negative number for the amplitude. Okay, and then if I trace it back, went up. Okay. So your amplitude will change your y-axis scale. Your b term in here is going to change the period, which then change your x-axis scale. All right, that's all I really need, hopefully, to be able to wrap up that last Math Excel required assignment of you. Good luck.